Hi, welcome back to the breadboard. In lots of my videos we use batteries and DC supplies for powering our projects. And what I wanted to cover in this video is a little bit about batteries and how they can be charged, etc., etc., and go back a little bit of nostalgia to my early days of building chargers and how they worked, and culminating in a new charger that I've just received from Banggood, which helps me to solve a lot of my modern day charging needs. So it's just on the board here, you can see you've got a lot of different things. Starting with probably the oldest would be these two battery packs right here. These are from remote control cars when I used to race them in the 1990s to early 2000 in the UK. They're both NiCads. This one is about 1100 milliampere hour, and there's 6 cells of about 1.2 volts, so that makes about a 7.2 volt cell. All the batteries are in series, and you've got just the one connector on the end of it. So if you want to charge it, you connect to here, pass a current through for a certain amount of time until you detect that it's charged. How did you do that? Well, in my case, I used to measure the temperature. NiCads have a feature where once they've peaked their charge, they can't take any more, all of a sudden they get very, very hot very quickly. So I had a homemade charger, which I don't have anymore, unfortunately, otherwise I'd show you, where it would measure the temperature, and the minute it started to see it rise, it would cut off the charge. It was very effective, and that's what a lot of us remote control car enthusiasts used to do to charge our batteries. If you charge them slowly, there are better ways of doing it that would make the batteries last longer, but when you're in the heat of competition at a car race day or something, you want to charge your batteries not quite as quickly as you discharge them, but you certainly want to charge them very, very quickly. So normal conventional methods that would prolong the life of the battery kind of went out the window. So that's what we used to do. This charger sitting here is the one that I actually used to use way back then. So this is 20, 30 years old now. It's actually 4 NiCads. You can set the current. It tells you the amps, and then this little LCD display would give you a reading of how long it took. So a little bit of simple math, you could figure out the capacity of your batteries, and it'll do discharge as well as charging, so that if you think your battery's getting a bit weak, you can fully charge it up, put it on here, and it'll discharge it, cut off at the correct point, and you can figure out what your capacity is based on the discharge current. So that was a long, long time ago. Now, one of the issues with these, and especially this one, is that the batteries sometimes would discharge at a different rate to each other. These cells are not particularly matched. They're probably from the same batch, but they came like this, already built in this pack. And the issue is when you discharge it, if one of them discharged a little bit more than another one, it would start going under voltage, and then you would charge the whole pack up again, and what you can end up doing is overcharging some of the other cells, which would increase their voltage, and still not fully charging the one that's going faulty. And then when you re-discharge them, and remember, when you're racing, you're discharging in 5 minutes maybe, this would go even further under voltage, and you can end up with a situation where with a heavy discharge, the faulty cell could actually get fully discharged, and because of the current passing through, even reverse charge, which would basically destroy the battery if you're lucky, cause a fire if you're unlucky. So those are NiCads. These batteries here that you can see, these are actually factory matched to try and minimize it, but they were still charged the same way. You would put a voltage across the complete pack, put in a certain current that was limited, maybe 10 amps or something like that. Take about 15 minutes to charge them, and you'd go and race, and you'd be measuring the temperature. This particular charger here doesn't go, it will charge up to 10 amps, but it actually measures the voltage profile of the battery, so it does a better job, but it will take a lot longer to charge the batteries under normal circumstances. Modern day equipment like hand drills and stuff like that, you know, they're all battery operated these days, would use a pack something like this. Now this is from an older drill pack, and again it's NiCads. This is taken out of the pack, and I haven't removed anything from it except for the plastic shell, and you can see there's no electronics here. So you know, these ones have 6 packs in. These have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 packs in. So 11.2, so that's 12. It's probably like a 12, 13 volt pack. I don't think that has any charge in it at the moment. I think it's pretty much dead. We can just quickly take a reading and see if there's anything left in it, but I'm pretty sure it's as flat as a pancake. Oh no, there's about 7.5 volts in there. But again, if you charge this, you can't balance all the cells out. So what happens, you know, if you've got single cell devices, kind of like this little ultraviolet little device I made. It's got a single LiPo in it, but it's just a single one, so that's relatively easy to charge. And I will, in a different video, show you a single cell LiPo charger that I have. But that's pretty easy. There's no balancing to worry about. You just put your 4.2 volts across it. You let it take whatever current. You charge it with a constant current until the voltage reaches 4.2 volts, and then you just let it trickle charge for a while after that, and you're pretty much done. That's for a single cell, and you don't get the issue about imbalancing. Now, modern day batteries, all right, and I'm not talking about things like this, which is a modern day sealed lead acid battery, so it's old technology. These are great for alarms and things like that. They can take quite a bit of abuse, but they're still old tech. But I'm talking about LiPo batteries and things. So you're talking about, say, laptop batteries. Right? Here's one that I've removed out of an old laptop. You can see I've already started taking it apart. And you can clearly see here there are some additional wires. At the very top you've got the red wire and you've got the black wire at the bottom. These batteries, by the way, are in parallel pairs. So it's 4.2, 4, 8, 12. So it's about a 12 volt pack. Okay, 4.2 is the fully charged voltage. These lithium-ion batteries nominally are usually about 3.8 or 3.9 volts. Does it say? Yeah, 3.7 for these ones. And they're 7.4 watt hours each. So probably 2 amp hour cells. Yeah, 2 amp cells each. So that would be 4 amps for the whole thing. And then times 3 sets. So 3, 6, 9. Yeah, 11, 12 volts, anyway, close to, near enough. But there are the additional wires. You've got the yellow one here and the blue one, and what they're doing is they're going to the chips that are on this controller card here. So we have a complete charge controller chip here. So you would have power coming in on this connector here, and then it would charge the battery, but this controller, along with some of the FETs and things like that, would ensure that the batteries are balanced. Now that's been built into laptop batteries ever since they went to LiPos. Older NiCad ones probably were the same as the power drill battery pack, where they just charged it and hoped for the best. No wonder we had so many issues with NiCads back then. So that's kind of what you get in laptop batteries. Now, a lot of modern products come with batteries built in, and they are removable. And here's an example. This one is primarily, well, it's got drone written on it. It's actually sold for quadcopters and model airplanes and things like that. But you can use this for pretty much anything where you want to have about an 11 volt supply, and this is 850 milliamp per hour. And in here is basically 3 cells, and they're 3.7 volts each, so that gets to about 11 volts. And you would charge them through this connector here, which is an XT60, and you can buy the XT60 connectors separately, so you can make them up onto your packs or attach them to some kind of charger, or your equipment would have one of these. You can get them on chassis mount versions as well. But how do you charge these and keep them all balanced as well, right? Well, what they've done is they've brought out the individual cell packs on this little connector here. And that's where we get to the charger that Banggood has kindly sent to me, which is this one here, right? It's relatively low cost. I'll put a link to the Banggood website so that you can get one for yourself if you want to. And they call this the B6 Light, half the height of an iPhone X. Who cares about that particularly? It can deal with 13 amps and 220 watts. There are some specifications right here. Input voltage input voltage DC 7 to 32 volts, so you're always going to need more than what your pack's going to be. Max discharge power is 5 watts. Max charge power is 220 watts. Max charge current is up to 13 amps, from minimum is 100 milliamps. Max discharge current only goes up to 3 amps. It will deal with LiPos, LiHV, so lithium polymer, lithium ferrous, LiOn, lithium ion, and LiHV cells. It will also deal with NiCad cells and nickel metal hydrides, and it will also do PB battery voltage. That's a lead acid battery, so it would even charge something like this if you wanted to. Okay, small weight, etc., etc. So let's have a look at what's in here and how you use it. Okay, so we've got a cable, we have a little device. Peel off the skin. One go. So we have a little device. It's got 3 buttons. Looks like they don't move, so they're probably capacitive. We have a DC input on one side. That's using an XT60. So we can plug an XT60 into it. And we have a output, which is also an XT60. But what we also have here is a 7 connector array, and that is designed to take these. Now I only have these what they call 3S battery packs, where there's 3 lithium-ion batteries in series, so it doesn't go all the way along, but this battery charger is capable of handling up to 6S. So that would be about 22.2, 23 volt battery packs for 6S. And what you do is you charge here the main current, but then this is used to monitor all of the individual cells as they're charging, and it will balance them to make sure that they're all at the same voltage, which minimizes the chance of damaging one of the cells during discharge and also during charge as well. You don't want to overcharge one cell just because a few of the other ones are running a bit flatter than the rest, right? That can happen either way. Got a display built in here, etc. So let's just get this powered up and we'll have a look at how it works. Oh, some of these other things, these are just obviously some legacy battery holders. They're still very popular today. You'd put in AAA batteries, so you'd get 1, 2, 3, 4 batteries in this one, 4 batteries in this one, giving you a about 6 volt supplies, because typical AAA batteries are 1.5 volts each, so 3, 6 volts. If you put in nickel metal hydrides, they're 1.2, so you get about 4.85 volts on them. Still good enough for a lot of projects, but because a lot of our electronics these days is either running on 3.3 volts or it's running on, say, USB 5 volts, then even a single LiPo is not enough volts. So you would either have to boost it up or you'd have to put batteries in series. All right, enough about some of the batteries. What about charging them? I've already mentioned how how we used to charge these NiCad batteries, and that's not what we're here for today. We're going to talk about charging LiPos. So let's just get a few things out of the way here. For charging LiPos, as I've mentioned already, you have, and the specifications are different for every LiPo from different manufacturers, but typically you can charge them at about 1C or 2C. A C is its rated capacity. So in the case of these ones, for example, that would be 2 amps because each cell, so there's 4 amps. So you probably, a 1C charge on this would be a 4 amp charging current because these are in parallel. Now these are factory matched and they're actually welded together, so you can continue to use them in parallel to increase your capacity. But if you were charging something like one of these pre-bought packs for model aircraft or racing control cars, or even any project where you wanted to have a little 11 volt 850 milliamp supply, you just plug it into your project, easy to replace. You want to be able to charge it and have it balanced and things like that. So that's where this comes in again. So let me just get this powered up. I'm going to use this 12 volt battery maybe. I might need more than that, but we'll see. And we'll get up and running. Okay, ready to go. I have the 12 volt battery supply. It's a little bit over 12 volts, I think. Let's just quickly check it. Might be slightly under, but it should be enough for this. Yeah, 12.5 volts. So not fully charged, but charged enough. I have a connection to the charger, to the battery for the charger. You need to be careful with this because obviously there's nothing stopping me shorting this battery out, and that has a lot of power in it. We have our target battery and we have our battery charger, and I've got a meter in case we need to check anything. Just move that out of the way for the moment. Righty, so first things first, let's power up the device. So this is our input DC, so we will connect our XT60. So first thing I notice is there's a fan there, showed us the version number, and it flips through to the last used settings. So you can see here, battery type is set for LiPo right now, 3 cell, which is these. Set for a charge current of 1 amp, a voltage, it will tell me when I've connected a battery, and it will tell me the capacity once we've done either a discharge check or how much capacity went into a battery. So if the battery was empty, it'll tell you its capacity. If it wasn't empty, it will just tell you the difference of what there was to what it put in. Menus in here. So what you would do is you push the right hand button, and now you can use the up and down arrows and change the battery type. So lead acid, NiCad, nickel metal hydride, lithium HV, LiHV, lithium ion, and then back to LiPo. So quite a range of batteries, which is good. When you've got the one you want, and in this case these are LiPos, you just press the enter button. Now you can set how many cells, and again, 2 cells, 1 cell, 6. So we've got 3 cells, so we set OK. Now you can change your charging mode. So right now it's flashing balance charge, which is what you would normally want for one of these. You don't have to do that every single time, but it certainly pays to do it on occasion. So you can easily scroll through the different charging modes. So you've got fast charge, storage. So if you're not going to use these for a long time, you want to reduce the voltage to somewhere between discharged and charged, so about medium capacity, so they last longer. So this will allow you to reduce their capacity down to that value. We've got discharge, and you can set the current here. Currently it's set for 0.5 amp discharge current. And you've got charge, which is not balance charge, so it would ignore the extra connector. And then you're back to balance charge again. So we're going to go with balance charge for this. And you press enter. Now you can set your charge current. Now these are 850 milliampere hour. So what we would have is 0.8 or 0.9. Press enter. And now it's ready to go. Now if I press and hold this button here, it will try and go into charge mode, but it'll beep and nothing's going to happen. If I hold it pressed to try and force it, it's going to give me an error because it's not detecting a battery. Alright, so what I will do now is I will plug in the battery. And plug in the connector. Make sure we get it the right way round. So the negative is the one that goes to here where it says negative. So even though you've got a red positive, that just means it's the same one as the main battery positive. And then you've got the cell nearest to the positive, the next cell, and then the bottom cell. So we plug that in here. And you can't really make a mistake because it's using the little detents that are on the connectors to plug in. So you couldn't plug it in upside down as an example. Alright, so that's plugged in. Now you can see it's detecting the voltage as 12.4 volts. So these are probably already charged. But now if I press play, come in. Alright, now it's charging. So it already thinks it's almost full. As you can see here, 97%. It's charging at 700 milliamps at the moment, and the voltage is 12.49. It probably won't take much before it just cuts off on us. Now, when we were going through the specifications for this, I'm just going to put this down a second. One of the things that it said here was that it can actually charge up to 220 watts, but it can only discharge 5 watts. Now the reason for that is that when it's charging, it will be using probably a buck regulator to provide a constant current into the battery pack. So there's not a lot of heat being dissipated in the charging device. When you're in a discharge mode, you are probably, you've got to dissipate all that power somewhere. So, you know, 1 amp at 11 volts is 11 watts. So you can't even discharge this at 1 amp because that whole 11 volts would have to be dissipated as heat inside this, and it's only rated for 5. So you would have to discharge at something like half an amp for this particular pack. And that's why it's limited to 5 watts, because there's a lot of heat. And as you heard when this first powered up, there is a fan in it to try and keep it cool. When it's charging, the full voltage is across the pack with the current, so the heat is really in here, but it's not dissipating it as heat while it's charging. It's doing a chemical conversion to store the power in here. So it's a very different process, which is why this can charge at a lot higher capacity than what it can discharge, because there is no real heat here, or at least a small amount due to component losses. But a buck converter is not something that gets typically really hot unless you get to very, very high power. And then relative to what you're supplying, it still is very little power in there. That's why they're so efficient. Again, this is a SkyRC B6 Lite from Banggood, and I will provide a link in the description for you to get one of your own. And these are very, very inexpensive. You can probably get one for so these battery chargers are currently sitting at about $45 US, and there we are full. $45 on Banggood right now, and you know, depending on the time of year, what sales and offers are on, you may be able to get one cheaper than that. So there's the cell fully charged now. Let's go look at doing a discharge check, see how easy that is. So LiPo, 3 cells, and we'll change this to say discharge, not fast charge, storage, discharge. And right now it is set to 3 amps, but it's probably not going to like that. Let's see. It may cut off with And then you've got the measure of the voltage here. I don't know whether there's other, you can't look at the cell voltages individually. You would have to get a more advanced pack than that. So you'd have to trust that it is doing balancing properly and things if you left it to do the balance charge. You can see that, like most batteries, as soon as you put a load on them, you get an initial drop, which is why it's probably already gone to 94%. Probably take a little longer to go down from there though. I'm not going to sit and make you watch this all the way through. The idea is to introduce you to this little low-cost battery charger from Banggood. You don't have to buy these great big expensive ones and things like that for your basic hobby charging needs. And as I said, this will work for charging, you know, any of your project batteries really, if you're using an XT60 connector, or you could make easily an adapter using low-cost XT60 connectors and just wire them into your projects. You pull it out, charge it, put it back in your project, and away you go. This is a lot safer in a lot of cases than trying to use mains-based power supplies, except for the fact that one of these can give you a lot of current. These can often give you 25, 50 times their rating. So this would be able to give out maybe 60 amps into a short circuit, whereas a mains-based power supply might only be able to give you, you know, a few amps if it's rated at that, and it will protect itself. So if you were going to use these for a project, you would, you know, need to make sure you have them suitably protected. We'll talk about batteries and things in a separate video. This one is about the battery charging. Anyway, so it's going to go on and on and on until the battery is discharged. And you can see here it's counting up the milliampere hours. I'll leave this going for now, and then when it's completed I'll come back and we'll see what the count gets up to. So before we go and fully discharge the pack, let's just quickly check what the individual cell voltages are. So overall, because it's just been fully charged, 4.2 volts, it should be about 12.6 volts. So here's the whole pack. There we go. So that's pretty darn good. Now, I don't know how easy it's going to be to check the individual. Oh, there we go. That's easy enough. So across the first two batteries from the positive, we've got 4.21, 4.20, effectively 4.2. So they're all within 10 millivolts of each other, which is pretty good. I'm sure if I left it on balance for a while, it would get better. I think there's about 20 millivolts difference across the whole pack. Okay, so now let's go fully discharge it and we'll see what it looks like when it's fully discharged. I'll be back when it's done. So there we go. Now we're done. And 903 milliampere hours, and as these things are rated for 850, I think that's good because it's obviously giving us a little bit more capacity right now. Anyway, that's a quick demonstration of using the SkyRC B6 Light charger. I'll be using this in videos again in the future, and as I said, this was sent to me from Banggood, and about $45 US right now, and I will provide links to it in the description so that you can get your own. If you liked the video, give me a thumbs up. If you didn't, well then don't. And I will be also looking at different charging technologies and DIY chargers and things like that in the future.